Hey guys, welcome back to the YouTube video. Sorry it's been a long time, but got a lot of things going on at the moment. So, well, first of all, I want to start off by saying that I'm not feeling well again. So, if you not being able to understand my voice because it sounds horrible, I do apologize. So, let's get to the presentation now. So, today we're going to talk about the worst planet in a solar system. And can you guys guess what it is? Well, it's Earth, the planet that we all live on. So, we're going to talk about the basics of Earth today. So, today we're going to talk about the water, the land, tectonic plates, diameter, interior, and how the Earth was formed. So, first, we're going to talk about we're going to talk about the Earth first. So, Earth is a third planet from the Sun and the only astronomical object known to harbour life. This is enabled by Earth being a water world, the only one in the solar system sustaining liquid surface water. Almost all of Earth's water was contained in its global ocean, covering 70.8% of Earth's crust. So, most of this planet that we're living on is actually covered in water. So, next we are going to talk about the water itself. Um, this is enabled by Earth being a water world, the only one in the solar system sustaining liquid surface water. So, 71% of the world is actually water, but only 5% of the ocean was in fact discovered, well, explored by human race. Only 5% of the whole sea is explored by human race. So next, water and land. So almost all of Earth's water was contained in its global ocean, covering 70.8% of Earth's crust. The remaining 29.2% of Earth's crust is land, most of which is located in the form of continental landmass within one hemisphere, Earth's land hemisphere. So only 29% of the world is covered by land, guys. As you can see on the graph, just a very small amount of the world is contained by land and most is water. So most of the world is actually water. So now we're going to talk about the land. Most of Earth's land is somewhat humid and covered by vegetation, while large sheets of ice and Earth's polar deserts retain more water than Earth's groundwater, lakes, rivers, and atmospheric water combined. So, of course, we not only we have oceans across the world, but we also have lake, river, and groundwater. And if you guys are wondering what the groundwater is, it's just basically normal water that you find underground, and this is what some household tap waters get. Sometimes they get from the reservoirs, sometimes we get it straight from underground. Um, so next we're going to talk about tectonic plates. So Earth's crust consists of slowly moving tectonic plates which interact to produce mountain ranges, volcanoes, and earthquakes. So the world is the ground, the surface of the world, whether it's above the sea level or below sea level, It's all divided by tectonic plates. So we have Eurasian plate, North American plate, South American plate, African plate, Somali, Indian, Australian, Pacific, and so on. And at the edge of the plates, you normally feel you would actually experience a lot of earthquakes. For example, here in Turkey, it's right next to the plate edge, so that's why a lot of earthquakes happen. And you probably all heard what happened to Turkey in February. Massive earthquake hit, uh, massive earthquake hit, guys, and 50,000 people lost their lives. Um, it happened in Marash, um, Mersin, and 8 other provinces in Turkey. About 50,000 people lost their lives here in Turkey, mostly in the east. So, yeah, so of course it produces volcanoes and mountains. So in the mountainous areas, you would see a lot of um, plate edges. That's where the plate edges are located, and that's why I see a lot of mountains in that area, especially between Nepal, China, and India. As in fact, the Indian plate is pushing upwards towards the Eurasian plate. So next, guys, Earth's diameter. So its diameter, the distance from one side to the other through Earth's center, is 7,926 miles, which makes 12,756 kilometers. Earth is slightly smaller when measured between North and South poles, which gives a diameter of 7,907 miles, which makes 12,725 kilometers. Hmm, that's interesting. So, between North and South Pole is actually smaller, as you can see on the map here. Of course, it's not too accurate compared to what is wrote here and what it says on the what's it called artwork, and because no one actually knows the exact numbers of what the real diameter is of Earth, but this is the approximate. But measuring from north to south pole is smaller than comparing to measuring one side to the other. So that's interesting, guys. Like Earth is slightly oval, not completely round. So now we're going to talk about Earth's interior. So first, we're going to talk about the crust. So crust is a thick outer shell of rock, referring to less than 1% of Earth's radius and volume. It is a top component of the lithosphere, a division of Earth's layers that includes the crust and the upper part of mantle. The lithosphere is broken into tectonic plates whose motion allows heat to escape the interior of Earth into space. Wow. So that's probably why we have plate edges, guys. If right in between the plate edges, the heat actually leaks from the underground, from the Earth's interior, and eventually goes out into outer space. Ah, the light's gone off now. So, yeah, so this is the crust, you guys, of Earth. So, next we're going to talk about the mantle, the second layer of Earth interior. So, a mantle is a layer inside a planetary body bounded below by a core and above by a crust. Mantles are made of rock or ices and are generally the largest and most massive layer of the planetary body. Mantles are characteristic of planetary bodies that have undergone differentiation by density. All terrestrial planets, including Earth, a number of asteroids, and some planetary moons have mantles too. So, yeah, this is what the mantle is, guys. The second layer of the Earth's interior is made out of rock or ice, but it's not liquid like lava. So now we're going to go to the outer core now. So Earth's outer core is a fluid layer about 2,260 kilometers, which makes 1,400 miles thick, composed of mostly iron and nickel that lies above Earth's solid inner core and below its mantle. The outer core begins approximately 2,889 kilometers, which makes 1,796 miles beneath Earth's surface at the core mantle boundary, and ends 5,150 kilometers, which makes 3,200 miles beneath Earth's surface at the inner core boundary. So, outer core is made out of liquid. So, um, let's say the lavas we see erupting from the volcano. Um, these are all the, the stuff that come from the outer core. It's liquid. It's not mantle because mantle is rocky, but outer core is a liquid rock. So the that's what the lava is, guys. All those things that comes out from the volcano is in fact pieces of the outer core that has leaked from underground, which is located 2,889 kilometers deep underground. That's very deep, guys. And 2,889 kilometers is approximate distance from the UK all the way to eastern Canada. So it's very far, guys, really far away, really deep, I mean. So now, outer core temperature. Estimates for the temperature the outer core are about 3,000 to 4,000 degrees in kelvins, which makes 2,700 to 7,600 degrees Celsius. So that's extremely hot, guys. That's about the same temperature as the sun. Well, not really as hot as the sun, but 7,600 is actually hotter than the sun's surface. Uh, so, so 4,800 degrees kelvins near the inner core, which makes 3,700 to 7,700 degrees Celsius of the inner core. So it's actually hotter than the sun's um, surface, and it's right beneath our feet, guys. Almost 3,000 miles deep, no, kilometers, sorry. So now we're going to talk about the inner core, guys. So Earth's inner core is the innermost geologic layer of planet Earth. It is primarily a solid ball with a radius of about 1,220 kilometers, which makes 760 miles, which is about 20% of Earth's radius or 70% of the Moon's radius. There are no samples of Earth's core accessible for direct measurements, as there are for Earth's mantle. Information about Earth's core mostly comes from analysis of seismic waves and Earth's magnetic field. So no one has ever accessed the inner core, not with remote underground machines. to take this sample from the inner core all the way inside our planet because it's too deep. So now we're going to talk about the temperature of the inner core. So, excuse me, guys. Sorry. Sorry, guys. So now we're going to talk about the temperature of the inner core. So the temperature at the inner core surface is estimated to be approximately 5,700 degrees Kelvins, about 5,430 degrees Celsius, which is about the temperature of the sun's surface. So yeah, like I mentioned, guys, same temperature as the sun's surface, and it's right beneath our feet. So very hot, guys. So do you think the inner core is the innermost part of the Earth? Well, uh, we actually have the innermost core, more deeper than the inner core itself. So scientists have long known about the fifth layer, a 400 miles wide metallic ball inside the inner core, fittingly named as the most inner core since it was first theorized in 2002. Scientists have confirmed its presence multiple times, most recently in March 2022. So it was only in 2002 when they first known about the innermost part of the core, which is the little ball all the way inside the Earth's interior, over 400 miles wide. Um, so quite big still, but not as big. 400 miles is a bit like between, let's say, between London and Birmingham in the UK. These two cities are about 400 miles in distance, which is quite far. So that's how big the inner core is, innermost core, the ball all the way inside the Earth's interior. So this is the Earth's interior charts. So yeah, like we said earlier, the crust is only 1% of the Earth's interior. And next we got the upper mantle, which is only 9%. Lower mantle make up of 33% of the Earth's interior. Same for the outer core, again 33%. Inner core 18%, and innermost core just 6% of the Earth's interior. So I'm actually quite surprised actually about the sizes in comparison with all these layers of the Earth's interior. So yeah, so now we're going to talk about the Earth's atmosphere. So we're going to talk about all the layers of the Earth's atmosphere. There's troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Thermosphere spelled wrong. It's supposed to be an R between the E and M, but that's missing. So that's a mistake for them. So now we're going to talk about the troposphere, the first layer of the atmosphere. So the troposphere is the lowest layer of the atmosphere of Earth. Excuse me guys, let me check something. Yep, still recording. So it contains 75% of the total mass of the planetary atmosphere and 99% of the total mass vapor and aerosols, and is where most weather phenomena occur. From the planetary surface of the Earth, the average height of the The troposphere is 18 kilometers. Makes about 11 miles high in the tropics, and 17 kilometers, which also makes 11 miles in the middle latitudes, and 6 kilometers, which is only 3.7 miles in the high latitudes of the polar regions in winter. Thus, the average height of troposphere is 13 kilometers, which makes um, 8.1 miles or 43,000 feet. So a lot of differences between the latitudes of Earth, of our planet. So I'm quite surprised about that too when I first found out, because I do research this first, guys, before I make the presentation, and this always gets to me. And then when hearing that there's actually different sizes in a troposphere between the locations of our planet. So now we're going to talk about the next layer called the stratosphere. So the stratosphere is a second layer of the atmosphere of Earth, located above the troposphere and below the mesosphere. The stratosphere is an atmospheric layer composed of stratified temperature layers, with the warm layers of air high in the sky and the cool layers of air in the low sky. Close to the planetary surface of Earth, the increase of temperature with altitude is a result of the absorption of the sun's ultraviolet radiation by the ozone layer. The temperature inversion is in contrast to the troposphere, near the Earth's surface, where temperature decreases with altitude. So this is always very confusing, guys. So um, warm layers of air high in the sky and cool layers of air in a low sky. So the higher you get, the warmer it gets, and the lower you get, the cooler it gets. And also the troposphere and stratosphere, right in between is where the plains are located. So you see a plains, or you're in the plane and you're at the highest peak in the sky flying to wherever you're going. Um, you're right in between the troposphere and stratosphere, right in between the two layers, more closely in the ozone layer. So now we're going to talk about the ozone layer. So the ozone layer, or ozone shield, the A region of Earth's stratosphere that absorbs most of the sun's ultraviolet radiation. It contains a high concentration of ozone in relation to other parts of the atmosphere, although still small in relation to other gases in the stratosphere. The ozone layer contains less than 10 parts per million of ozone, while the average ozone portion of the stratosphere, from approximately 15 to 35 kilometers, which makes 9 to 22 miles above Earth, although its thickness varies seasonally and geographically. So now we're going to talk about the mesosphere. The mesosphere is a third layer of the atmosphere, directly above the stratosphere and directly below the thermosphere. The mesosphere Temperature decreases as altitude increases. The characteristic is used to define limits. It begins at the top of the stratosphere, sometimes called the stratopause, and ends at the mesopause, which is the coolest part of the Earth's atmosphere, with temperatures below minus 143 degrees Celsius. The exact upper and lower boundaries of the mesosphere vary with latitude and with season. Higher in the winter and at the tropics, lower in the summer and at the poles. But the lower boundary is usually located at altitudes from 47 to 51 kilometers, which makes 29 to 32 miles above sea level. The upper boundary, the mesopause, is usually from 85 to 100 kilometers, which makes 53 to 62 miles. So, about 60 miles in space is roughly where the satellites are located and orbiting around our Earth, our planet, and this is where the mesosphere reaches, and its temperature is below minus 143 degrees Celsius. So extremely cold, guys. And also, this is where the auroras are located as well, in the mesosphere, where the what's it called? Um, when the sun throws its flares out and creates a solar wind, sometimes they reach Earth and create an aurora. And aurora height is where the mesosphere is. And you can see on the picture here of the mesosphere, and you can see a bit of an aurora peaking in the horizon, which is coloured in green. And mesosphere and asteroids. The mesosphere is where the asteroids burn out before reaching stratosphere and creates a shooting star. So yeah, so they burn out 60 miles high above ground. So that's why they never reach the ground level and hit the Earth's surface if they're quite small. But if they're very big guys, of course they can reach our surface and create a phenomena. So now we're going to talk about the thermosphere. The thermosphere is a layer of the Earth's atmosphere directly above the mesosphere and below the exosphere. With this layer go to the atmosphere, ultraviolet radiation causes photoionization or photodissociation. You can write down in the comments, guys, if I'm pronouncing this word wrong. Of molecules creating ions. The thermosphere thus constitutes the larger parts of the ionosphere. The thermosphere begins at about 80 kilometers, which makes 50 miles above sea level. So about the same actually compared to the mesosphere, because mesosphere is actually about 62 miles, but thermosphere, which they say is higher than mesosphere, is actually 50 miles above ground. Well, sea level to be exact. So that's what I'm finding a little bit confusing, guys. So now we're going to go to exosphere now, about 10,000 kilometers above sea level. So the exosphere is a thin atmosphere-like volume surrounding a planet or a natural satellite where molecules are gravitationally bound to that body, but where the density is so low that the molecules are essentially collisionless. In the case of bodies with substantial atmospheres, such as Earth's atmosphere, the exosphere is the uppermost layer, where the atmosphere thins out and merges into outer space. It is located directly above the thermosphere. Very little is known due to lack of research. So we actually don't know how much the exosphere actually expands out in the outer space, which is the remnants of the main part of the atmosphere that comes from the Earth's ground and heads out to the outer space, but we don't know exactly how far out it goes to and disappears forever. So, yeah, so how did the Earth form? Well, guys, we're going to talk about that in the next video. Because the reason why I'm going to make another video of the planet Earth, because I don't want to make this video too long and too boring for you guys. So that's why I want to divide this video into two, because there's a lot of things to talk about our planet. So we're going to have part 2 video coming very soon. I've already started working on the presentation for the part 2 video. So hopefully I'll be able to upload tomorrow, but I'm not sure because I'm not very well. I don't know how am I going to feel tomorrow, but I will upload as soon as possible, guys. So in the next video, we're going to talk about how water and life formed. And also we're going to talk about the other things happening on Earth, like the greenhouse gases and how we're affecting the world as we're using constantly the gases, smoke, and causing greenhouse gases, and so on. So this is what we're going to talk about in the next video, guys. So yeah. So after part 2, we're going to talk about Mars. So Mars is the next planet from Earth. So this is what we're going to talk about after the part 2 video, which will come out very soon, guys. So yeah, so thank you guys for watching. It is a very long video today. That's why I want to divide it to part 2, so it doesn't have to be too long for an hour. So yeah, so guys, thank you so much for watching. I do apologize once again because I'm not feeling well. Yeah, I just woke up this morning feeling under the weather, but yesterday I was completely fine. I don't know why I'm ill again. I was ill 2 weeks ago. Um, so I don't know what's going on with me, guys, lately, but so yeah, it didn't stop me from doing this video, guys. So guys, thank you so much for watching. Hope you all have a great evening tonight. Don't forget to hit the thumbs up, subscribe, turn the notifications on, and that's it. And I'll see you in the next video. Cheerio.